Section 8.4 is on page 480 and starts with trigonometric substitution. In this section, the goal is to eliminate the radical. Radicals are very hard to maneuver around. This section deals with specific type of radicals, and the remaining radicals will come up as we do the remaining sections 8.5, 8.6, and when we do the chapter review, which we're going to spend a long time on, then you're going to really see a lot of deals with radicals and the u sub. For now, we're just going to apply how this works. Remember, when I look at a problem, I should attempt the u sub first. That might solve the problem, and there's nothing quicker than the u sub. In this case, obviously, if I let u equal 1 plus 4x squared or 4x squared, du wouldn't be the x, it'll have an extra x. So that's not going to work. Well, in that case, I would look at the table. I do see a radical, and I do see two squares. So what's taking the place of a? It looks like 1 squared, and it looks like 2x squared is the matching pair here. So let a, well, what's a? What do you square? So let, I'm sorry, not a. Oh boy. I messed up on those, forgive me. There we go, much better. Wow. I just wrote those a minute ago. That's the deal. So whoever came up with this had the identities in mind, and that's really how they figured out what to use. And I'll show you how that plays. All what that does, if you let, so what's taking the place of a, 2 is taking the place of a. I'm sorry, 1. So let x, what's taking the place of x, I should say. I should start backwards. So if I glance at this, I could think of this as the square root of 1 squared plus 2x squared. And what's taking the place of x? I'm going to let 2x equal 1 times the tan of theta. And if I take a derivative, 2 dx will be secant squared of theta d theta. This would become the integral of the square root of 1 plus, and if I substitute in place of 2x tangent, wouldn't that become simply tangent squared? And wouldn't the x be a 1/2 secant squared of theta d theta? And if I really work this out, this is actually 1/2 the integral of secant squared of theta d theta. Wouldn't this radical become the square root of secant squared of theta? Isn't that just secant of theta? And wouldn't this simply be 1/2 the integral of secant of theta? And as you recall, we agreed you were going to memorize those three identities for me. Isn't that natural log of secant of theta plus tan of theta plus c? Now what's wrong with me leaving the answer like that? Look at the original problem and look at what you're leaving. That's unacceptable. And why is that? Because we started the problem with x. That's why you always have to come back to the original substitution, whatever those are. You're going to say, I let 2x equal tan of theta over 1, and there's no way around this. If I create my triangle, this is the opposite over the adjacent. There's theta, opposite over adjacent. The hypotenuse would be the square root of 1 plus 4x squared. And what I need out of this, I need the secant. Secant is the hypotenuse over the adjacent. And I need the tangent, which is the opposite over the adjacent. And there it is. And that's the only way we could do this problem. There is another way, but it's not that far from this. Let me do another problem. So pretty much in this section, all what they do is eliminate the radical out of the equation, and that takes you to the previous section, a combination of either sine and cosine or tan and secant, and you use the appropriate identities. And let me go to the next. And on this problem, problem number 4, actually I'm gonna change this a bit here. I want to maximize the space. So this is an identity I should have memorized. Meaning what? We agreed that you were going to memorize that the integral of dx divided by x squared, a squared plus x squared, is 1 over a, the inverse tangent of x over a plus c. That was an agreement. And if you didn't, you're behind us already, and that's going to catch up with you, right? And all what you have to do is make an adjustment there. Now assume you didn't see that. Even though this section deals with those three, but it turns out to work even if there are no radicals. It works on almost anything. The only reason we really don't apply this to every problem, as you see, the process is lengthy and kind of challenging to students. So if I follow the same trend and say, you know what, let's say this was a radical, wouldn't you let, and let's see how this works. What do you square to get 3x squared? Isn't that radical 3x? And what do you square to get? And you notice everything is messy. What happens if you factor a 3 out? Do you notice that makes your life a lot easier? Do you have to? Of course not. But it's much easier to play it this way. And one of you could say, you know what, I don't remember this. And this is your alternative. So one of you will look at this problem and say, wait, I got this memorized. I remember what this guy said. This is 1/3 times 1 over, what do you square to get for 1 over a, the inverse tangent of x over a, and you're done. This is one of you. Or somebody else will look at this and say, you know what, I don't remember that. So that's, I'm going to let, so somebody else, and this is the price. And here it's really short. This could take a lot longer. Let x equal twice the tan of theta. Dx is twice secant squared of theta d theta. This would be 1/3 the integral of 4 plus. And if you square this, you get 4 the tangent squared of theta. And dx is simply twice the secant squared of theta d theta. And if I clean this up, this would be 1 over 3. I'm going to factor a 4 out of those and a 2 out of the top. I'm going to have secant squared of theta d theta over 1 plus tangent squared of theta. That is 1 over 6 times the integral of secant squared of theta over secant squared of theta d theta. Those cancel out. That's 1/6 the integral of d theta. That is 1 over 6 times theta plus c. I can't leave my answer with just theta because I started the problem with an x. I go back to my original substitution, original, right there. If x equal twice the tan of theta, doesn't that mean tan of theta equal x over 2? And what does theta equal? The inverse tangent of x over 2. So either you get to the answer in one step, or you could do all of these steps. Honestly, I can care less. Unless I see that final answer, I'm not going to let it go. Oh my god, here, I messed up. We said A. A was, what do you square to get a 4? That was a 2. Ah, look at that. Caspi would have nailed me on points on that one. This guy's unforgiving. Alright, let's do another one. Number 6 prime. When I see a problem like this, again, I'm glancing at it, so I'm trying to match it. And I'm thinking of a squared minus x squared. So a is 1, obviously. And what do you square to get 9x squared? Wouldn't you say that's 3x squared? So I'm gonna let 3x equal, and a squared minus x squared, right there, the very first one, it's a sine. A, again, you don't have to write the one, I'm just writing that for your notes. 1 times the sine of theta. What that does, that's going to guarantee that the radical will disappear and I'm left with sine and cosine. And in the previous section, we determined how to do that. If I take a derivative, 3 dx will be the cosine of theta d theta. So I know I'm going to have to divide that by 3. If I let this be the sine, so that is the square root of 1 minus. When I square both sides, I get the sine squared of theta. And I know what that is. Wouldn't that be cosine squared? Isn't that just cosine of theta? There. That's simple. And dx, isn't dx really a 1/3 cosine of theta d theta? And what do you notice happens here? This will be 1/3 theta plus c. That is 1/3 of what? Theta is right here. If I isolate, doesn't this say that 3x equals sine of theta? So what's theta? Isn't that the inverse sine of 3x plus c? I don't know if you had that memorized from the previous section or not. You do realize that this is the derivative of an inverse sine or negative cosine, not that it matters, but the 3 stands in the way. If you know that, good for you. If not, here it is. Another problem I want to do is problem number 10. And there it is. If I want to work out this problem, well, the same deal happens. I look at this, I see a radical. Again, I aim for a u sub, but it doesn't work in this case, right? So I'm going to say, well, let's see. I'm comparing this with the square root of x squared minus a squared. What's taking the place of x? What do you square to get 16x? So I'm going to let 4x equal. And what do you square to get a 9? 3. And if you have x squared minus a squared, it's a secant. And 4 dx will be 3. Derivative of secant is secant of theta, tan of theta, d theta. Of course, I'm going to divide by 3. And if I let the 4x be this, if you take 4x and you square it, wouldn't that be the square root of, when I square both sides, isn't that a 9? So here, if I write this as 4x squared minus 9, wouldn't that be 3 secant of theta squared minus 9? And this 3 I'm going to drag up front, and do you notice what dx equals? That's going to be an extra 3/4 the secant of theta tan of theta d theta. So I went from x to theta. This is 9/4 the integral of secant of theta tan of theta d theta. And this radical I'm going to work on the side. That's 9 secant squared of theta minus 9. That's 9 into secant squared of theta minus 1. That is the square root of 9 tan squared of theta. So that is a 3 times the tan of theta. These 3's cancel out. That's 3/4. What's the integral of secant? Isn't that natural log of secant of theta? And do you see why I had you memorize those 3 identities? They arise a lot more than we like. And that's the only reason I have you memorize them, instead of you deriving those every time. That is 3/4 natural log, and let's not make the mistake of leaving the answer in terms of theta, because the problem started with an x, my answer should be in terms of x. The only time you could avoid what I'm going to do right now, if this is a definite integral. So I'm going to go back to the original. It says 4x over 3 equals secant of theta. And if I draw my triangle, secant of theta. Theta is the hypotenuse over the adjacent. That makes this the square root of 16x squared minus 9. Okay, I'm not liking that at all. Oops, come on. Time. So I am in quadrant 1. Again, this is the hypotenuse over the adjacent. That makes this the square root of 4x when you square it, 16x squared minus 9. So I want the secant. That's the hypotenuse over the adjacent. Tangent is the opposite over the adjacent. And that would be my final answer. I want to tackle one more of those. And that's the equivalent of number 12. Again, U sub doesn't work. So here I'm gonna let what? I'm gonna let x equal a is what is squared together 9, 3, and x squared minus a, according to the table, that's the secant of theta. Dx is 3, I was gonna say cosine. The secant of theta, tan of theta, d theta. Oh man, I could write better than this. So if I make my substitutions, I'm looking at, let's see, my u is right there. So that's going to be what? That's going to be 3 secant of theta squared minus 9 under the radical, right? Dx is all of this. Dx would be 3 the secant of theta tan of theta d theta. And remember, there's another x right there. That would be 3 the secant of theta cubed. Now, the radical I want to work out on the side. So here I do know that this is 27 the secant cubed of theta. 3 the secant of theta tan of theta d theta. The only piece I want to work out is this piece. That's the square root of 9 the secant squared of theta minus 9. The reason we make those substitutions, so this will work out every time. Not 9, 1. I factored the 9 out. That will be 9 the tangent squared of theta. So this is 3 the tan of theta. There we go. Now, if I clean this up, this is the integral, and let's see how this works. That's a 9 divided by, so 27, that's a 3. I'm looking at a secant cancels with the secant, that's a 2. So I'm looking at tan squared of theta over secant squared of theta d theta. And how would we work such a problem? That is 1/3 the integral, and there are a couple of ways you could do that. Now, if I let u equal the tangent, derivative will be secant squared, that's not helping. But if I take the top, wouldn't the top be tangent? Isn't tangent secant squared of theta minus 1? Wouldn't that be 1/3 the integral of, and I'm going to split those up, something we're going to be playing with a lot more than we like. Isn't that 1/3 the integral of 1 minus, and isn't 1 over secant the cosine squared of theta? How do you like that trick? Isn't that 1/3 the integral of, and isn't this sine squared of theta? And there's only, of course, you could have wrote this as sine squared over cosine squared and cosine squared and saved yourself a lot of time. Normally, this is the way it works. This is my warning to you. if you see secant and tangent, and the rule of secant tangent doesn't work because that's in the denominator, write everything in terms of sine and cosine. Tangent is sine squared of theta over cosine squared of theta. And if you move this up, that becomes cosine squared of theta, and there it is. You could have saved yourself these steps. Not that it matters. Sometimes you don't see it, sometimes I don't see it, you know. And there's only one way of doing this problem, and do you remember how that works? This is 1 minus the cosine of 2 theta divided by 2 d theta. So, this is 1 over 6 times theta minus the sine of 2 theta divided by 2 plus c. Well, guess what? I need to go back to x. We have a problem. This is easy because I could say secant of theta equal x over 3. This is the secant inverse of x over 3. I could say also the cosine of theta equal 3 over x, and it doesn't really matter. This is fine. The problem is this piece. Minus, isn't that twice the sine of theta cosine of theta? There is no way around it. Isn't that secant inverse of x minus sine of theta cosine of theta plus c? What does sine equal? Well, I need the triangle. So I tried to avoid it all of this time, and at the end, guess what? I'm back to it. The original, and it's right there. Secant of theta is the hypotenuse over the adjacent. That makes this the square root of x squared minus 9. So this is 1 over 6, the secant inverse of x, minus the sine is the opposite over the hypotenuse, and the cosine is the adjacent over the hypotenuse. And that would be my final answer. Let me get you the homework. And there's our homework.